Hey everyone, I'm Ben Gromicko from INTERNACHI. That's the International Association of Certified Home Inspectors. And today we have a special guest on NACHI TV, NACHI.TV. If you go there, there's where we do free live webinars, probably one or two a month for home inspectors. Available to everyone, open to everyone. It's free, it's online, and every webinar is video recorded and we put it up on our YouTube channel so you can watch it later if you can't attend or you got to do a home inspection. Today we have Paul from Energy Conservatory, and he's going to talk about blower door and building science, blower door tests, blower door inspections, the value of blower doors, and energy audits and building science for us home inspectors. And it's one of the things that home inspectors can get into. Blower door, you could rent one, you can own one, you stick it in the front door, and the idea is you either pressurize or depressurize a building, and you find a lot of things like, well, primarily air leaks. It's amazing how much a building breathes or really loses air. Every home has ventilation, and what we don't want is an old home or a brand new home, any home, to lose a lot of air. And what we as home inspectors do is we go up into the unfinished attic space and we take a look at the insulation and the ventilation and the structure up there. Do you ever grab like a fiberglass blanket, a bat of insulation, pull it up, like maybe the yellow or the pink fiberglass, and there's like this black mark on the underside? That's not mold, that's dirt, because the fiberglass insulation is really like a big filter. It's a filter glass. And air is escaping from like the interior walls and other areas, going right up through the insulation and right out the house. And when air escapes a house, money goes with it, because that's just an energy loss. So as home inspectors, we could educate ourselves on what information would be really good for our home inspection clients related to energy. And when we find problems, what can we do? Maybe we could hand off the information and educate our clients and give them a contractor, maybe a home energy performance contractor or an energy auditor, or someone to come in and do a blower door test so that they can air seal and then insulate. So that's what I'm really interested in. And with all the energy and climate news going on, maybe that's what home inspectors could be interested in as well. Paul, are you available?
Yes.
Awesome. I'm going to give you the controls of the webinar, and you can take it from there.
Okay. All right. Yeah. Thanks for that great introduction. And blower doors are certainly becoming more and more commonplace as building codes start requiring blower door tests. Most states require blower door tests for new construction now. So it certainly would be a great market for home inspectors to move into. We're going to be talking primarily about blower doors, but anytime you talk about blower doors, you have to touch a little bit about building science, so you better understand how air moves through a house and those kind of things. So I've been with the Energy Conservatory for over 10 years now, doing tech support and training. We are the manufacturer of the Minneapolis blower door and duct blaster systems, and we sell these all over the world. My first career was carpentry. I did framing as a carpenter for about 15 years and made the transition to doing energy audits for a weatherization program in 1991. So I've been using this equipment for a long time. The Energy Conservatory started making this equipment in the early 80s. So this is not new technology. This has been around for a long time. We will start. We'll talk about what is a blower door, just get down to the real basics of what is a blower door, talk about some air leakage basics, setting up and performing a basic blower door test, what the results mean, how to find the air leaks, and why air sealing is important, and some unintended consequences. We'll get into that also. So it's primarily used as finding locations for air leaks. That's the big advantage to the blower door, is you can find where those air leaks are and seal them. But it's also used to verify the quality of work and measure improvements. If you're a contractor and you want a starting point and see how much you're improving it, it's great for that, or for quality control after work is done. And it gives you a way to quantify how much of your energy bill is related to air leakage. And experienced insulators that use blower doors will do a blower door test when they're going out and doing a sale, and it shows a certain level of professionalism, and they can determine the potential energy reductions based on doing the air sealing, and then they can confirm also that it's done. A lot of comfort is impacted by air leakage. If you've got cold drafts or hot humid air getting into your house and leaking through your house, it really does affect the comfort. And it gives you the advantage of being able to set mechanical ventilation rates based on for new construction. Mechanical ventilation rates are based on the size of the building and the occupancy of the building. But with existing homes, you can determine if it's tight enough to need mechanical ventilation, or maybe after some air sealing is done, you're to the point where you may need mechanical ventilation. So you can use that blower door to help determine that. Code compliance, I mentioned that. Most states require blower door testing for code compliance now. Certifications like a home energy rating will require blower door tests. There are some utility programs that have incentives for doing air sealing, and blower door tests are required for that. Certification and compliance now are kind of meshing and melding a little bit more. Starting with the 2015 International Energy Conservation Code, you've got an option to go on an energy rating index, a certification index that is your path for code compliance. So those two are kind of, compliance and certification are starting to meld with new construction now. Some air leakage basics. You do need both a hole and a driving force to get air movement. An example of that would be if it's 70 degrees inside and 70 degrees outside, and you open a window and it's a calm day, what happens? Nothing happens. There's no air movement through that hole because there's no driving force. Some of the driving forces, you may have heard of stack effect, and stack effect is a function of how tall the building is and the temperature difference between inside and outside. One easy way to think of that is air has weight, right? It gets lighter as we go up into the mountains and heavier as we get down towards sea level. Also, cold air is heavier than warm air. So if it's colder outside than it is inside, that cold air on the outside pushes down on the earth more, and that forces air in on the lower part of the house. And physics says that air in must equal air out, otherwise our house would implode or explode. So the pressures equalize each other, and air will leak out of the upper part of the house. In the middle of a house is what's called a neutral pressure plane, and that's where half of the leaks are above that point and half are below. And when it's cold outside, the farther you get away from that neutral pressure plane, the stronger the pressure of air either moving in or out. So when it comes to air sealing, the place that you can get the biggest bang for your buck, where the pressure is the highest of air leaking out, is between the house and the attic. for air leaking out in cold weather. In warm weather, this stack effect, you get a reverse stack effect. So now the air is coming in the top part of your house and leaking out on the bottom. And that's why on a two-story house, we think hot air rises, and that's why it's hotter on the top floor. But part of that is air is also leaking in from the outside on the upper part of your house. So you're getting heat from that 140-degree attic leaking into your house too. So that's the place where you can get at and seal the most air leaks after a house is constructed, and have the biggest effect on comfort and energy savings.
And that's one of the places that our home inspectors who are infrared certified that use an infrared camera can really enjoy their work, because boy, in the summertime, if you scan with your infrared camera the second floor bedroom ceilings, where the kid is having a different environment experience than the rest of the house, you can see along the edges, especially near the eaves, usually an indication of something abnormal.
Right. And so yeah, this image kind of dramatically shows the stack effect in this building. You've got plastic over the windows, and you can see it being sucked into the building on the lower floors, and the upper floor it's blowing out. So the neutral pressure plane you can see pretty definitely is between the second and third floors, and air starts moving out at that level. Wind is another driving force that certainly causes air to move. It'll blow in on one side of the house and blow out on the other. Another effect is the different mechanical systems will affect airflow through a house. When you have a natural draft or induced draft furnace, natural draft water heater, fireplace, when air is going up the chimney, that changes the pressure in the house slightly, and air will be sucked into the house to replace that air that's going out through a chimney. Exhaust fans do essentially the same thing, whether it's a clothes dryer, kitchen fan, bath fan. When you turn on the exhaust fan, it exhausts air out of the house, and instantaneously an equal amount of air will leak in. And it'll leak in wherever it can. It changes the pressure in the whole house and causes air to leak in from the point of least resistance. Interior door closures, along with the air handler running, can change pressures in houses also. If you have a bedroom with a supply and no return, and you close an interior door, that will pressurize that room. And now any leaks, any holes, air will move across any holes. Some of the holes will be around that interior door, air will go underneath that door, but any leaks to the outside, air will leak out also. And remember, air in has to equal air out, and it will cause air to leak in through the rest of the house to replace the air that's being blown out when you close that door. So mechanical systems, an air handler, and closing doors that have supply and no return can cause pressures in a house that drive infiltration and exfiltration, both. This is a good image that gives you ideas of some of the places where air will leak into a house. Certainly, any sill plates or rim joist details, those details have lots of cracks and lots of places where air can leak in. And in air leaking out of the house, you can, if you've got a chaseway going from the basement all the way up into the attic, like in this case, it's showing a chaseway for a B vent for a furnace. And that's warm, so that's going to drive the air even more. And you can have leaks all the way from the attic down the basement. I've seen leaks where you could drop a tennis ball from the attic and it would bounce off the basement floor. So big air leaks. And like was mentioned earlier, if there's fiberglass insulation around that, you pull that back and it'll be filthy from insulation. Doesn't stop air movement. It just filters the air and makes sure the air in the attic is clean. So other places drop soffit details in kitchens and bathrooms. Sometimes over the cabinets you'll have a drop soffit detail. A lot of times they may have recessed lights in them, and those recessed lights are designed to have airflow through them to keep that can cool, and that air can leak right up into the attic too. And you think about interior walls, they're going to be room temperature, and that warm air, in this case, typically those drop soffits were framed before it was sheetrock. So you can go up in the attic and you can reach right down into that air cavity, that wall cavity, and so that air is just rising right up through the insulation up into the attic through those kind of details too. And then certainly electrical wires, switch plates, air can leak right through there up into the attic. And you definitely see that when you're using an infrared camera along with a blower door. You can find where those electrical penetrations are in the attic. When you turn on the blower door, it pulls the air back down in the opposite direction and pulls that air down the wall cavities. Around attic hatches, certainly if they're not weather stripped well, they'll leak. Any plumbing penetrations, plumbing vents, you'll get air leaks around those also. So there's a lot of concentrated air leaks in bathrooms, which are real humid environments, and that air moving into the attic will bring moisture with it and can lead to condensation problems and roof decks rotting over time, caused by that moisture getting up into the attics above bathrooms. And I'm sure anybody who's spent a lot of time in attics has seen their share of that. Another detail that's common in story and a half homes is that space between the floor and the ceiling, the joist space, is room temperature again, and oftentimes that's open into a side attic, and that warm air will just move right up into that attic space. And you know, those of you in cold climates where you have frost or snow on a roof, you can see by melt patterns where the air is leaking, where there's missing insulation or where air is leaking because the frost melts off first there, or you can see the snow isn't as deep, or there's bare spots on the roof where the heat is escaping either through air movement or lack of insulation. So that's on the left is showing our blower door system, and typically you will, in most cases, you'll depressurize the house. So you're blowing air out of the house and causing air to leak in from the outside. It will put the entire house under the same pressure, so pressure changes by the same amount everywhere, as long as you have doors openings between floors and between rooms. You'll get an equal change in pressure throughout the house, and so the pressure across all the leaks will be the same, and it gives you a good representation of the total amount of air leaks. The pressure we put the house under is 50 pascals or 0.2 inches of water column, if you're familiar with water column. And that's not a pressure that the house doesn't see normally. It simulates about a 20-mile-an-hour wind, only it's coming from all directions. So it's not pressures that the house doesn't see normally. So people are often wondering, you know, if they have an infant or pets, is this pressure gonna harm them? It's certainly nowhere near the amount of pressure that you feel when your ears are popping when you're going up in an airplane or down a steep hill or something. It's certainly not that kind of pressure. So it's certainly not going to do any harm or damage to anything or anybody.
Hey, Paul.
Yes.
What if the house has a like a fireplace, a chimney that goes outside, and you've got a blower door? Is it just shut shut the damper door, or do you have to actually, maybe seal it up a little bit better than that?
Well, first of all, you do want to make sure the damper's closed. If you have
Yes,
ashes in the fireplace and you don't
I've
close
done
that,
that.
yeah, I have too, unfortunately. And it doesn't look good in a house with white furniture or white carpet. Um,
Right.
it definitely pulls ashes down everywhere. If
Yep.
and we would certainly, before doing a blower door test, when the appointment is being scheduled, we would ask homeowners to clear out the ashes. But oftentimes you get in a house and there are still ashes, and none of those old dampers seal tight, so there will be some airflow. So what I would do is, this was a while ago, but I used to always ask for newspapers and spread newspapers over the ashes, and that way they don't spread. Newspapers are kind of a rare thing these days, so you might need to bring some paper with you to cover over the ashes in the fireplace, just to make sure you're not kicking up ashes. If they have, a lot of fireplaces now will have doors that will close in front of them, and then it's not going to be an issue. But if it's an open hearth, then it's a good idea to cover those ashes up to make sure you're not going to spread them around the living room.
But it's one of those things that's always open normally. So it's one of those things also that you wouldn't seal with sealant, air sealant. So
Right.
I always thought it would be one of those things that you would want to close up more than just the damper in order to do a good blower door test.
Yeah, I have seen people who will, if you never use your open hearth fireplace, um, you could cut a piece of foam and push it up in there. I would certainly recommend having a string coming down with a label on it saying remove this before you start a fire. But you can make with like couch cushion foam, only is dense, a much denser foam, but pushing that up there so it makes a good air seal, and just leave it in there, because it
Yeah.
certainly is, that is a leak that's going 24/7.
Yeah.
They don't seal tight, and they do leak. Um, so we'll go over setting up the building for the test, and certainly you want to have a protocol for setting up the building, because your blow door test won't be repeatable unless the building is set up the same way every time. And we certainly recommend closing all windows and exterior windows and doors. And I would take it a step farther and say lock all of the windows and doors, because that pulls it up a little bit tighter and gets a better seal. And then you're sure that, that way you're going up to every window and making sure it's shut all the way and locked. It's not that the locking makes it that much more airtight, but if you leave it open a quarter of an inch, that can be a big leak. So you want to make sure they're all closed. And I would go the extra step of locking them for the test. Also, you want to determine is if it's got a crawl space or basement, is that conditioned or unconditioned? And keep in mind that the pressure boundary and thermal boundary, you should be aligned, so you can kind of tell by, sometimes a basement ceiling will be insulated, but the pressure boundary really is the outside walls and not the ceiling. So it's not always obvious how you should set up for the test, but you wanna have a systematic way of setting up the house for a test. Attached garage, should that overhead door be open or closed? If you have a porch that's unconditioned but has storm windows, should those storm windows be open or closed? All of those things can affect your results. So you want to make sure you have a systematic way of setting up the house. So if you come back and do the test, you'll get the same results. Then we'll talk about setting up blower door equipment and performing the test. So this is these are the three parts that come with the blower door system: the frame, the accessory bag, and the fan itself. So we'll open the frame bag, set out the pieces on the floor, and connect them. So you can see you want to push in that that button and slide it in, and it'll snap into place. And the frame is gasketed to make a good seal around the door opening. Then you'll adjust it and tighten the cam lever, or tighten the screws to get it approximately to the size of the opening. And then the way I do it is I'll just put the red nylon panel over the door and then push the frame up against it there. And then you can see there's Velcro there, so you'll pull down the Velcro and then push it into the opening, and then adjust it so it'll fit tight in the opening. And then there's a cam lever there too, that you throw the cam and it gives it a little extra push against the frame to get not only a good seal, but to hold the, you're going to be applying a 20-mile-an-hour wind blowing on that frame, and you don't want it to pop out of the opening during a test. So after you get it tightened down, you want to pull on the top part of the frame and make sure that it's in there tight. Most people who do a lot of blower door tests have gotten hit in the head with the frame a couple of times, and then they learn you got to make sure and get it in there tight enough. And then the way we measure the difference in pressure between inside and outside is using tubing. So we'll run a piece of tube to the outside and have that away from the fan, so the flow of the fan isn't going to affect the end of the tubing. And we'll drop the fan into place. There's an elastic band that tightens up the seal around the fan. We'll pull that around, and then a Velcro strap goes through the handle on the fan and then around that crossbar, and gets the fan snug in place. And they're putting a hanger bar on that frame and putting our gauge board on there. So the gauge and the fan speed controller, you can see those two cables running down from the speed controller. We'll plug one end of those into the fan and the other end into a wall socket. We'll put the pressure and flow gauge on there that's held on by magnets onto that gauge board. So you can see the rheostat for adjusting speed, and now the gauge is turned on. And we'll use the tubing assistant, that app that's on the bottom. It's a touchscreen gauge, and the app on the bottom is a tubing assistant, and that helps us. It's kind of a tutorial on setting up the gauge, and it asks us 4 questions. The first one is, what kind of test are you doing? Are you doing a building envelope test, a duct tightness test, measuring the airflow through an air handler system, or using some of the other devices like measuring exhaust fan flow? We're doing a building tightness test. Are you pressurizing or depressurizing? Most often you'll depressurize or blowing air out of the house. If you have a case where you suspect there's mold in the wall, maybe you're investigating a mold problem and you suspect there's mold in the wall, then you want to pressurize so you're not pulling those spores into the house. So there are instances where you would pressurize and not depressurize. Is the pressure and flow gauge in the house or outside? Your tubing connections will be affected by that. And then which fan are you using? So once you have those 4 questions answered, then it will show you how to connect the tubing. And each channel A and channel B, there's 4 taps all together. One is an input, one is a reference. And it's measuring the pressure difference between those 2 locations. So it's telling us on channel A reference to run a tube to the outside. Channel B input goes to the fan. So it's going to measure house pressure on A, fan flow on B. Then we'll go to the home screen, and we'll connect and this is kind of a close-up of that home screen. Now we went through that setup, so it set up our fan, which fan we're using, flow at 50 because we're doing an envelope test, or we're testing at 50 pascals. It set our cruise for 50 pascals, so we can use the cruise function and have the the gauge ramp up the fan for us, or we can grab with, touch with our finger and pull the fan speed across the and turn it up that way, or we can turn the knob on the fan, so you can run the speed up a couple of different ways. And then where it says open fan here, open fan is for big leaky houses. As houses get tighter, you need to, the reason we have different size flow rings on the fan is because we're actually measuring a pressure at the flow sensor, and then we're converting that pressure to flow. And the pressure needs to be high enough for us to get a good reading. If the pressure is too low, we need to make the opening smaller, so it'll raise the pressure. So you can think about like an air handler system. If you have a big duct, the pressure isn't very high in the system, but as you start making that duct smaller and smaller, if you're moving the same amount of air, the pressure is going to get much higher. So by making the hole smaller that the air is moving through, it'll raise the pressure up high enough so we can get accurate readings within the calibration range of the fan. So to change that ring, we'll touch on where it says open fan there, and the screen will come up, and we're going to choose ring A in this case, so we'll choose ring A, and then we'll connect the tubing. Now we can see a pressure on the A side, and it's at about -1.3 is our baseline. So we wanna set that baseline. We're going to subtract that -1.3 because we want the pressure in the house to change by 50 pascals. We don't want to just bring it up to 50. We want to change the pressure in the house by 50. So we set the baseline on the gauge. So we click on that button, and then it starts averaging. On the right side, it counts up in seconds, and on the left side, it's going to be a time-weighted average. And once that stays, it's going to get more and more stable as we add more and more seconds to it. And once it stays the same for about 3 or 4 seconds, then we can enter that number in. And when we enter that number in, it subtracts that. In this case, it subtracted that 1.7 from our reading. That number will still fluctuate. If we have a little bit of wind, it'll still float around, but we subtracted 1.7 from that number, so we're going to get a change of 50 pascals. Then we want to remove the rings, and the rings that we have it set to ring A, so we'll leave ring A on there. And now we'll, in this case, we're just turning the knob up until we get close to 50 pascals. We have it set in pressure flow at 50 mode, so it's not on the right side. That's not the CFM moving through the fan. It's what the CFM would be if we were at exactly 50. So it's doing a conversion. So the flow that it's showing is at 50. So as long as you're within a few pascals of 50, you're going to get an accurate reading. So that's it. As fast as you can turn the knob up, the pressure in the house will change. So the actual testing it to get a reading part of it goes very quickly. Okay, and then so that'll give us an air leakage at 50 pascal reading, and then we'll want to normalize that leakage based on the size of the house, and that's done either using air changes per hour or CFM per square foot of enclosure area. I like the metric of square foot of it, CFM per square foot of enclosure area, because that's where a building leaks, right? That's where the holes are. You're trying to measure how big are the holes in the enclosure area, so it makes more sense to normalize it based on the enclosure area size. Current codes ask for air changes per hour, though. In most of the country, it's 3 air changes per hour. In some of the southern states, it's 5 air changes per hour. But that's slowly changing. In commercial buildings, the code is based on square foot of enclosure area. So it's kind of moving that direction. It should move over that direction in time. You can do a multi-point test too, use software and have the software control the fan, and you can do that now with an app on your phone. The gauge has Wi-Fi and Bluetooth, so you can connect to your phone and run a blower door test from your phone and then generate a report and email it or send it up to the cloud. Multi-point tests, what that means is you're taking readings at 50 pascals, 4540, 3530, 2520, 15, and then it uses all that data to determine a more accurate reading. And then also, you know, when the test is done, what the accuracy and repeatability of that data is also. So on a really windy day, you might want to add more data points or run the test again. So you'll have you know, much better level of confidence in your reading when you do a multi-point test. Finding where the air leaks. Go ahead.
Jim asks, should you open all the interior doors and closet doors prior to starting the test?
Yes, you definitely will want to have. Closet doors aren't as important because that's a really small volume, but certainly you want to open all interior doors during the blower door test. So we're testing the house as a single zone. Good question. Finding the air leaks, using your hand, you can certainly feel where air is coming in with your hand. A smoke puffer helps find it a little better and helps quantify it maybe a little better, or showing a homeowner it's a better visual. Using infrared cameras, certainly when I started in the early 90s, infrared cameras were close to $20,000. Even 10 years ago, a good infrared camera was $5,000. Now you can buy a decent infrared camera for about $600, and it's just a device you snap onto your cell phone. And they take, there's pretty good quality ones now for about $600. And I think a lot of home inspectors do already have infrared cameras, so you can already find areas of missing insulation with that if you've got a temperature 10 degree or so temperature difference between indoors and outdoors. And you can find some air leakage, but only on the part of the house where air is leaking in. If air is leaking out of the house, you can see it somewhat from the outside, but it's always best to do it from the inside, because things like vinyl siding or aluminum siding really play havoc with where is the air leakage and what are you really seeing. And infrared cameras can be tricky. You need to know the emissivity of what you're looking at. Sheetrock isn't really affected by that. I'm not going to go into a lot of detail about infrared cameras, but it's really easy to misrepresent infrared cameras. It's worth going through a level 1 training if you're going to get serious about using infrared cameras. Zone pressure diagnostics, there is a way to determine how much air leakage there is, for example, between a house and an attic, and that can be critically important for an insulator if he wants to determine where's the best place to air seal. If you know how much air leakage there is between the house and the attic, you know not only what the potential is, but if you've gotten it all. So those are techniques that require some software and some knowledge, but it's out there and it can be done. Or if you have an area like a moldy crawl space and you want to do a perfect job air sealing between a house and a crawl space, there are ways to do tests to determine if you've gotten it all.
Paul, you're saying air seal and sealing the air leakage. A lot of home inspectors, we're training them on this recommendation, because historically a lot of home inspectors will go up in the unfinished attic space. They're required to approximate the depth of the insulation and try to figure out if there's a defect or not, or a deficiency. And then their recommendations are often just add more insulation. Would you recommend tweaking that recommendation to include air sealing?
Oh, absolutely. Yeah, if you do insulation without air sealing, you can actually cause problems.
Yeah.
An example of that would be attic condensation. So in cold wintertime um, conditions, that any of that air that leaks into the attic is carrying moisture with it. And if you add insulation, you're going to make that attic colder, and you're more likely to get condensation. And if you're bringing the same amount of moisture into an attic that you were before, and now the attic is much colder, you can cause some pretty serious problems. And the effectiveness of the insulation is really diminished by not sealing the air leaks first. And it just makes it way harder for the next person coming in to do the air sealing if you've got extra insulation up there. So it is really critical that that the air sealing be done.
Yep.
And we'll show you some quick infrared images. Black is cold in these images, white is hot, and when you turn the blower door on, you can start seeing where the air leakage is, and in this case, it's leaking right down into some drop softening details. This one was air leakage from between a house and a garage, where that wasn't sealed properly. This one, there was a cantilever over the front of the house, and a lot of air leakage through that cantilevered section and down through the recessed lights. Recessed lights they're designed to allow a lot of airflow to keep them cool, and this that streaking across the ceiling is a classic sign of air movement through a recessed light. And attic hatch the same way. In doors, we can feel air leaking through doors on a windy day, but you can just see it dramatically with an infrared camera.
Hey, Paul.
Yeah.
Mike asks a question. There's a couple questions about unfinished attic spaces. A house that has a walk-up attic and it's not finished and it has no heat supplied to it, should you have that door open or closed during a blower door test? It's closed, yeah?
If it's not a conditioned space, then you would have the door closed.
Yeah, and it's not finished. Yeah.
Yep.
Yep. The idea is to close that door and then watch how much air leakage is through that door to the unfinished space, from heated, conditioned air to airspace to that unfinished attic space.
Right. Yep.
And then, sorry if I mispronounce it, Anio, is there a way to do a zone pressure test for the attic space to determine ventilation efficiency?
Yes. Actually, when you do the zone pressure diagnostics, it does tell you the results in that software will be how much air is leaking between the house and the attic, and also how much air is moving from the attic to the outside. And you can determine, it will also show you how many square inches of opening area there is. So it'll definitely tell you what the net free opening area is of your attic venting.
Cool. Okay.
So this image is showing you how you can see missing insulation. So in this case, it's colder outside. Black is cold, so we can see our rafters are colder than the space between them. So the space between them is insulated. Have better insulation value in the space, so it's warmer. But over to the left side, you can see where there's some missing insulation, where the cavity in that space is colder. So you can see areas of missing insulation by looking at the temperature of the studs. Unintended consequences. Tighter homes may need mechanical ventilation. You know, if I think back to, I'm a grandfather myself, but I think back to my grandfather's generation in the homes that they grew up in. They didn't have insulation in walls or attics. They didn't have clothes dryers or kitchen fans or bath fans. And though if the wall cavities got wet, there was enough energy and enough air movement where those wall cavities stayed dry. But that's certainly not the case in homes now. We wouldn't, people wouldn't want to live in homes that were that leaky or uninsulated. as they were back in those past generations. And a lot of changes have happened in my father's and in my generation, where homes are certainly getting much tighter. We're adding kitchen fans, bath fans, clothes dryers. Kitchen fans are getting bigger and bigger. And a lot of times now, when you turn on a kitchen fan, it could potentially backdraft a natural draft water heater. Or for sure, if a kitchen fan and a clothes dryer were on at the same time, you can have problems. So, and the need for mechanical ventilation as homes get tighter and tighter. The air quality gets poor in a house, and CO2 levels rise, and it's not healthy to live in a real tight home without mechanical ventilation. So doing blow odor tests can help tell if the home needs mechanical ventilation. So it's good practice if you're going to be making changes to a house, whether it's adding a kitchen fan, adding bath fans, or making the house more airtight, that you do a test to make sure that natural draft appliances aren't spilling their exhaust into homes.
Now,
and the way
in relation to unintended consequences, like you said, are the same criticisms of doing a blower door test, do they still exist? Like when they first came out of doing a blower door test, many people started saying, "Oh, you're gonna suck in the moisture from the outside into the wall cavity and cause mold, or you're gonna suck in radon gas, or you're going to change the indoor environment, maybe even suck in asbestos into the air," and things like that. Are those criticisms of doing a blower door test still exist today?
There certainly are issues where if you have mold in your walls, and that's when you would want to do a pressurization test instead of a depressurization test. If you have vermiculite in your attic, and there's not a consensus with vermiculite in an attic whether you should do a depressurization or pressurization test, or whether it matters. So that's still a debated item. Some people will check for vermiculite in an attic before they do a blow odor test, and they'll only do pressurization tests. That's not consistent across the board. There's not an agreement on that, but certainly it's a technology that's been around since the 80s and is been well vetted over time, and is required in most states for code compliance. So I think those concerns about doing a blow odor test have been dispelled.
Okay.
So what we recommend for a safety test is turn on any device that could change the pressure in the house: clothes dryer, exhaust fans, air handlers, close bedroom doors that have only supplies and no returns, and then start up the water heater and check it for spillage, natural draft water heater or a natural draft furnace. Using a smoke puffer to see if the exhaust is going up a chimney, or a mirror actually works pretty good. If you put the mirror up against the draft hood, it'll fog up if there's spillage. The best method is to measure the temperature coming out of the draft hood, and if it's 35 degrees above the ambient temperature, that indicates that you have about 10% of the exhaust coming in the house. But most of the time it's not either a little bit or none. It's either all or none. where the house is under enough pressure, so it's a complete downdraft where all the exhaust is coming in the house. So I think we've pretty much used up our 45 minutes, but I could stick around and take some more questions if anybody has questions.
Yeah, if anybody has any last minute questions, please on Facebook or during the webinar in your webinar system, please post it right now. Mike says, yeah, he was told not to do any kind of blower door test if he suspected asbestos in the house. So there must have been. Is there a standard by which If I am a home inspector, I'm not doing the blower door, but maybe there's one taking place and I've been hired to oversee it. Is there a standard by which blower doors, energy auditors using a blower door, perform a blower door test? Is it ResNet,
Yeah,
BPI?
ResNet has standards. BPI has standards on for blower door testing. Weatherization programs, low-income weatherization programs are in every county of every state, and they're weatherizing homes for people who qualify for energy assistance, and they have standards. There aren't consistencies across all of those programs in every state across the country on how to deal with asbestos. I would certainly, if there's clearly a lot of friable asbestos in a basement, for example, maybe around boiler pipes or around even around some heat duct, sometimes there was asbestos. If that's clearly friable and any air movement across it could cause it to become airborne, I wouldn't do a blower door test, either positive or negative. I wouldn't be comfortable with that. So that if you see a lot of that in your area, I would certainly be cautious. And people who have mold allergies, you know, if you're doing a moisture investigation and somebody has some really bad mold allergies, you need to be real cautious also. And typically pressurizing a house would be the way to go. And if you find that there's a lot of air leakage through walls or air leakage between a moldy crawl space and a house, there are certainly big advantages to dealing with that air movement as part of a solution. But I've got into homes doing moisture investigations, mold, looking for sources of mold, and people are having severe allergies. One person in the house is having severe allergies to mold, and I couldn't find anything. And I've gone into other houses where they're having an energy audit done and it has nothing to do with mold, and there's mold everywhere in the house and it doesn't bother the occupants at all. So it's kind of all over. If people have mold allergies, you definitely need to, even if you can't see it, you need to be extra cautious.
A few questions. Justin asks, what is the cost of a unit?
The blower door system, complete blower door system, is about $3,500 now, and that includes the DG1000 pressure flow gauge, and all of our apps and software are free, and it's easy to get through for tech support too. You know, when you call, somebody actually answers the phone, and you get through to somebody right away. So that's what we pride ourselves on at the Energy Conservatory.
We have another question. How can you become an energy auditor?
Usually it depends on what type of energy audit you're doing. The two most common there's three kind of common things that would be in the energy audit field. One is doing it for code compliance, and that's actually the easiest branch to get into, because you don't need to know a lot of building science. You're basically running a blower door and getting a reading. If you have an agreement with the builder that if you fail, you'll help them find where the air leaks are, then that's kind of another level of sophistication. But just setting up the equipment and doing a blower door test is kind of the entry level. And BPI has a certification for that. You don't even need to take a class. You can just take the test, a field test, and make sure you're confident in being able to do a blower door test and a duct leakage test. And that's called envelope and EDL, envelope and duct leakage certification. And BPI does have an energy auditor certification, an envelope professional, and the energy auditor one is kind of the basic level one. And that's another level of certification. And a lot of the low-income weatherization programs require a BPI certification, so you'll need to be certified before you can work for them.
And Jay asks, what sources does Paul recommend for purchasing a blower door and other equipment?
We sell direct, or we sell through a network of distributors. So you could go either way. And so whether you purchase from a distributor or not, we still provide the tech support.
And it's energyconservatory.com.
Right, energyconservatory.com is the website. And we currently don't have, you can't order over our website. You'd have to call to place an order.
How long does the average test take? Say a 2,000 square foot house, 2-story home, something like that.
So if you're doing it for code compliance, where you're just going to pull up to the house, set up the house in test conditions, run the test, and then pack up your equipment and go, you could, once you're proficient at doing blower door tests, it would be probably 20 to 25 minutes to do all of that. So it's pretty, you know, it's not a lot of time. And actually, you know, like I said, as fast as you can turn the knob, it'll change the pressure in the house. So it's the setup that's set up and tear down and getting the house set up for the test that takes the most amount of time. And typical, you know, what I hear from people is for that type of blower door test, the going rate is somewhere around $300.
And a duct blaster test is something a bit different.
Right. With that, you have a smaller fan and you're using a flex duct to connect that to the duct system. You're sealing off all the registers with a register sealing film, and then bringing the ductwork up to pressure and taking a reading at that pressure. And that's a little more time consuming than a blower door test. That could be more like an hour instead of a half hour, you know, somewhere in that range.
Yep.
And it depends, you know, certainly if the house is unoccupied, it's easier to get at all the registers. If registers are hidden under beds and things in an existing home, it's going to take you a little longer.
And Justin asks, I was thinking that this could be an easy upsell to a home inspection. Is there an InterNACHI certification course? Yeah, actually there is, and it's free and online. We have probably 30, 40 hours of free online training with videos of BPI and ResNet energy auditors, trained energy auditors. So you can just watch the videos, you can take the courses, you can take quizzes and exams if you want, and see if you're really interested in it before investing in a really expensive training course. Brian says, what is the recommended cost for doing the test? How often do you think this test could be added to a home inspection? Well, this is kind of like a business practice, I guess. So you mentioned you had a $300 idea, Paul, in mind. You heard?
Yeah, $300 is what I've heard that is kind of the going rate for a blower door test for new construction. If you're going to do additional diagnostics with an infrared camera and documenting that and providing a report, you guys know how that goes. But roughly, when I was doing those kind of investigations and either indoor air quality or energy, I would spend twice as much time on a report as I spend in the field doing the diagnostic testing. So you certainly, if you're going to provide a report, you have to charge a lot more, other than just a simple report of the results.
Paul, I want to thank you very much for taking the time out to speak to us and do a webinar with us. It was really great, getting a lot of thumbs up. It was really helpful to a lot of inspectors who are attending and watching the video later probably. So I want to thank you for doing that for us.
Okay, great. And my phone number and website or email address are on there. And our website also has a lot of our past webinars. So if you're looking just for more information, um, check out energyconservatory.com and look at the past webinars.
Awesome. Thanks, Paul.
Okay.
Bye, everybody. Appreciate it.
All
See you
right.
next
Thank
time.
you.
Thanks, Paul.
Yep.